Hey everyone, thanks for coming. Appreciate everyone being here. I'm Principal Program Manager now in charge of the Server Monitoring Group, which includes the AWS work, as we just mentioned. And so we're going to talk a little bit about that, but what I really want to chat about is some trends that we're seeing in the industry, and we saw from our use of Docker and seeing how our customers are using Docker, and sort of applying those lessons to where we think things are shifting from a containerization point of view, around the cloud, around Docker, around how we're doing compute, around microservices, which is always a big buzzword, and sort of how are we thinking about how we're building applications. And since, hey, we're in the monitoring business, what's the kind of monitoring solutions we need to be able to provide to you to want to sort of skate to the puck to where we think the industry is going, and provide the right kind of monitoring solutions to you so that you can understand it, as you're engaging with these new technologies like Docker, moving into the cloud, even things like Lambda out in the future. What's the best way that you can understand what you're building by using a monitoring solution which is built according to those principles? So let's get started here. I was going to do an interpretive dance for the safe harbor slide, but then we're kind of running out of time, so I think I'll just skip that part. So if you want if we have time after, we can do the interpretive dance out in the hall, or questions. There's a number of shifts that are going on there I think are really fascinating, and one is containerization and Docker. And I don't know if any of you have tried. How many of you have tried Docker? Yeah. And it's pretty cool stuff. And one of the things that I think is really neat about Docker, I mean, everyone loves the fact that you can run it, you write it one place, you can run it in test mode, you can run it in dev, you can run it in production, the same stuff. That's great, that's awesome, right? Takes a lot of the friction out. It's lighter weight, so use less resources, you get more bang for your buck, that's really great. But one of the really interesting things about Docker that we don't talk about so much is that the containers are really fast to start up. And so it's a combination of all these about sort of like that frictionless development cycle combined with the fact that they're really fast to start up is we're seeing customers using Docker in new ways. And what I think is cool about Docker is because it's a new technology, there's no book on the right way to use Docker. We're all sort of discovering different ways of using Docker. And so I think it's actually a really interesting kind of test bed for understanding microservices, understanding lighter weight forms of computation. And so we've got Docker, ECS, they're doing some cool stuff there as well. And then Lambda. How many of you are familiar with Lambda? Less so, okay, yeah. You know what, Lambda's really cool. I really encourage you to go check it out. Lambda is basically zero config deployment. What you do is you write a piece of code, there's some triggers that you can register for. So the canonical example they have is if you want to create thumbnails, what you do is you listen for changes of your S3 bucket where you're dropping in images, and it'll and you have a thumbnail program, and it'll automatically run that and as many of them as you need. And all you have to do is basically tell them how much memory you need, which is sort of a proxy for how much power you want out of the system. And they'll just go run them as many as you need and wherever they need to be run. There's no AZs, there's nothing to config other than saying how much memory you need and the code that you want to run. And I think this is actually really liberating from a development point of view because it says that you, the developer, get to focus on the thing that provides value, which is just focusing in on the code and not worrying about all this other infrastructure. And so that's why this sort of term of the serverless future, which is kind of ironic I'm talking about serverless future since I'm the product manager for the servers group, so I'm kind of putting myself out of a job here, but serverless future, and I think that's sort of where we're trending is how can we eliminate sort of all of the muck work of having to worry about infrastructure. You kind of think about going from on-prem to the cloud, that's a step in that direction, and these as computational vehicles are extending that even further. And so if all you're doing is running a block of code and it runs as many of them as you need, how do you know what it's doing? And especially if you've got a whole bunch of small ones, how do you know what it's doing? What's the right way of making use of it? So, boy, that's a lot for that one slide. But that's I wanted to sort of frame up the discussion about what I think, what I'd like us all to be thinking about in this presentation, and which is really sort of I want to have a dialogue with you in a sense about it. And so to sort of tell the story from the beginning, so we were using Docker internally in New Relic. We're building out, our system is based on a set of services that under the hood, New Relic is a set of services that run in Docker. And we saw that Docker was catching on, and so we needed to monitor Docker, and our customers were adopting Docker. So my team built the Docker monitoring solution. And so as we were going through that, we were thinking, well, I wonder how customers are going to use this, because we're building out this new Docker monitoring solution. We're trying to understand, it's fresh. There's customers that are just trying to adopt it. A lot of customers were just sort of kicking the tires on it. So again, there weren't a lot of best practices you could really look at to understand what the right way of building a monitoring solution was. But we were using it internally. And how we were using it, as I said, was as, in a sense, kind of like a lightweight VM, which I think is where a lot of people start with Docker, because it's sort of like what you would have done with a VM, now you use Docker for instead, and you get all these efficiencies that we talked about. So we were sort of thinking of it as a lightweight VM. And then meanwhile, so this was early in, we had a closed beta, we had a total of 49 customers in the beta as we're working through building out the Docker monitoring solution. And we saw this huge uptake in the number of containers being reported in 24 hours. And we're like, wow, same number of customers, but they were really adopting this quickly. This is amazing. And all of a sudden, I walked in one day. Of course, since we're in the monitoring business, we have screens up in our offices with our software. So we're tracking usage. In this case, it was a Duxboard chart of usage of our Docker monitoring solution to see how our customers are using it. And I saw this huge drop. And I walked in and I looked at my engineering manager. He says, I'm on it, because I thought, we had a crash. That was the only logical answer, was we have some bug in the system and we just dropped all the data, or we just kicked out all those customers or something. It turned out it was one customer who had accidentally spun up 20,000 containers and didn't realize it, and then shut them all off. And it was one customer that was responsible for that huge spike. Since we only had 49, that one customer was really able to drag that peak around. And so I thought, we thought, that's kind of interesting. It's interesting the fact that, first of all, they didn't notice, but also, and hey, couldn't they use a monitoring solution for that? But it was also interesting in that it was a sort of use of, when we talked to them about what they were doing, it was a use of Docker that was closer to what you would think of as EC2. And so in that sense, I think Docker, what we're seeing is it's kind of being used like on-prem cloud, because it has a lot of those agility things that you get from the cloud and efficiency of provisioning. And because of those things we said, where it's lightweight from a resource point of view, from a startup point of view, you can use it like an EC2. So that was pretty cool. But meanwhile, we were building out our synthetics product. Not this team, but New Relic was building out the synthetics product. And they're using Docker, and they're using it. If you're familiar with synthetics, you give it a Selenium script to run, which we run on your behalf to test your endpoints. And because we want to do that in a secure fashion, we run each Selenium script in its own Docker container, because Docker's fast to start up, and it's got all the security isolation that you require. And so it's actually a really cool use of Docker. Well, these things only run for a minute. And so we're like, okay, that's different, because that's more like Lambda, where Lambda is just you give it a function, it goes and runs it for you, and then when it's done, it's done. It stops, right? And so it only runs when you need it to run, because it's got work to do, and these really, really small workloads. And so I thought, okay, that's more like Lambda. And we're like, what the heck's going on, right? How should we build a monitoring solution for this? What's the industry doing here? Because the type of monitoring solution that you would build, even just from a UI point of view, if you're using VMs and you don't have so many of them and they live for a long time, or you're using Lambda where they come and go really quickly, the kind of solution you would build for that would look different. So we wanted to sort of understand what our customers were doing. And we're like, hey, we're data nerds. We can go and analyze the data, because we can do aggregate data, of course, on usage patterns. And so we did a study, and we took a period of time. We were watching how customers were using it. And it was about 1,000 customers, and it was several million containers, I think nearly 10 million containers. And so we looked at all these usage patterns, and we broke it down into how long the containers were living for. Because that's what we thought was the interesting question through all this, was what's that life cycle of those containers? And are they being used like long-running VMs? Are they being used like short lambdas? Are they being like medium-term like EC2s, where maybe you cycle them up and down as you need more availability, or you're doing rolling deploys, or those kinds of patterns? And so this is the data that we got. And it's number of hours along the horizontal axis, and it's number of containers along the vertical axis, and that's 3.7 million at the top there. And you can't see it because it's lost in that axis, but there's actually data points up to 3.7 million at that 0th point of age. And I'll drill into the data in a moment so you can see what's going on there. But there's a few things to note. One is at the extreme end, it's 333 days. Now, we haven't had a Docker monitoring solution running for that long, but we can get that data from Docker to find out when the containers were started. What we don't know is if you started them and stopped them before you started monitoring with New Relic. So that's why along here you can see it's a bit sparse through once you get out to the right, and that's just because we don't have those data points available to us. But I think it's fair to say that that there's a kind of even distribution through there. We just don't have the data points because we haven't had a Docker monitoring solution for long enough to collect them. But it looks pretty even when you look at it. And in fact, if you sort of kind of look macroscopically at the patterns here, you can see that sure enough, all of these have about the same amplitude here, right? And they're all 100, there's about 100 containers or less for, this is about, I think it was like 33 days here. So in fact, this spike here, we'll talk about in a moment, is about a month boundary. So all these have sort of the same shape, and that's kind of like what you would expect from a VM where it's long running. And then, but more interesting is more at the front here. And like I said, so this here is about 1 month, and we think there's a spike here because people are doing rolling deploys maybe on a monthly basis. And so, but you'll see that the amplitude is much higher. And so that's a kind of, and lots more data points as well. So that suggests that I think that more and more people are using Docker as this kind of on-prem cloud in the same way that we use these EC2s, like I said, for doing rolling deploys, for doing scale out, for doing batch jobs. Now, where it gets even cooler is if you look at the front here. And I'll drill into what that looks like, but that's kind of like what you'd expect from Lambda, where it's just going to run for a short period of time. And in fact, what we found was that, and this really surprised us, was that 46% of the containers that we had counted lasted, were at that under an hour there. So this is up 24 hours, and they're in that first hour. And in fact, what really surprised me was that there really isn't, I would expect to kind of like histogram sort of drop off here, a sort of long tail gradual drop off, and there isn't. You got a little bit in hour one, in the next hour, and then there's not much after that. And this is a pretty big sample size too. So, and it's all production use as well, because typically people use New Relic in production, not, for example, for dev. I mean, there's some use of it. So I think we're pretty confident that this is representative of what people are using, how people are using Docker. And so next, if we drill in even further, so now we're in under an hour, and you can see that there's 11% of the containers were under a minute. And if we look even closer, we'll recognize that 27%, over a quarter of the containers that we had measured, lasted for under 5 minutes. And this was very surprising to us, much more than I would have expected. And that suggests that, again, we were talking earlier about some of the advantages of Docker, about how fast it is to start up a Docker container, is allowing people to use it in these ways, like we're using it for synthetics, which you would never use an individual. You'd never start up a VM just to run one Selenium script and shut it down. And maybe you'd run an EC2 container, but even still, EC2 containers are more expensive to get set up and to run. And so Docker was a really nice technical solution. And I think if we were to do it again, maybe we'd use Lambda this time. Lambda wasn't available at the time, but maybe we'd use Lambda. But it's that kind of pattern. And so where does this lead us? Is that the surprising result was just surely from a count point of view, there's way more use of Docker in these short-lived cycles than in the longer ones. Now, in some ways, it shouldn't be too surprising, because if you take a long-running thing and instead of keeping it running for a long time, you just sort of run it and stop it whenever you need it. So maybe doing batch jobs or something. If you take a long-running thing and you chop it up into short-running things, you're going to get a lot of them. So in that sense, it shouldn't be too surprising. But it definitely suggests to us that there is a trend going on. Objectively looking at the data, we can see there's a trend going on in the use of these technologies for shorter length life cycle work. And of course, this changes how we think about, in a sense, programming. You're not going to have, much like Lambda, you don't have something sitting there running all the time. A VM might not be doing very much useful work for a lot of its life. While as once you get out to using these sort of short life cycles, then you know that you're getting sort of, they're only running for as long as you need. Now, there's lots of ways we can talk about the data. If we had more time in this talk, I'd love for us to just kind of have a meetup sort of in the middle of this discussion to talk about what we think is going on, because we're all data nerds, we're all data scientists here, and this is just data that we're looking at, and these are some observations we made. You might have some different ones. I'd love to have that discussion with you, because I think it's quite fascinating. What I want to show you here is that we ran the same data a number of months ago, back in June. And in fact, Abner in New Relic, he wrote a blog article on it. And that's the one on the left. And then what I just showed you is the graph on the right. And you can see that the one on the left is sparser back from June because we didn't have as many customers using it. But it's the same shape. It's the same shape. And so that gives us confidence that this is a long-term trend that we're seeing. So where we got to here is that sort of thinking about, instead of thinking about instead of thinking about hosts of hardware, on-prem hardware, or thinking about it as an operating system, or thinking about it as a VM, thinking about it as an EC2 container, when we start just thinking about it as computation, and sort of computation as a service. And I think that's where we're going, is computation as a service. You need some work done. You're going to pick the technology that allows you to focus in on the thing that adds value, which is the code that you're writing. And you need computation as a service to do that, and where it's efficient, and it's easy to use, and it's low friction, it's all these things. And you don't want to worry about all the rest. And that's where I think we're seeing Docker going. And that's definitely where Lambda's at, which is why I think this Lambda's really cool, and you want to look at it at least as a sort of industry trend. And where there's this notion that containers, whether they be EC2 containers or Docker, we're seeing this trend where they get created, they do their work, and then they go away. And so they only exist for as long as they're providing value, and then that full stop. And that's sort of the story with Lambda, which is their sort of spin is that they say, well, it's much more cost efficient because you're only running the thing when you're actually doing the work, and that's all they bill you for, versus an EC2 or a VM that could be sitting around for a long time, just kind of hanging out, not doing anything. In fact, there's one of the stats read was that 30%, it was over 30% of infrastructure, both in the cloud and on-prem, is sitting, they call it comatose, where it's not doing anything, it's not providing any value. And so, of course, you can either try and build tools, like monitoring tools, to help you find that, or you can change your programming model to be more efficient. And that's the trend that I think is going on, which is really cool. So where does that lead us? So what does it mean from a monitoring solution? And it means that having lists, one of the things about these short-running containers, and that there were so many of them, is that having a list of them isn't that useful. So having a list of all the EC2s that you ran, or the Docker containers you ran, if you're only running them for a minute, that's not going to be, it's not going to be a very useful view of it. So instead, you start to worry about, well, maybe all I care about is throughput, or I care about throughput and how much it's costing me to run the stuff, or you start to think about other ways of understanding the costs. And in fact, I think when you think about the cloud, cost is a performance metric, because in the cloud you can just apply more resources. You can either spend more time making it more efficient, or you can just swipe your credit card and then and get more EC2s or more capacity or more whatever you want, and it'll come out in the bill. But you can get there faster without having to change the code to make it more optimal. So in that sense, cost is a performance metric, and that's I think where we're heading, because of the elasticity of these things. And so and the other thing is that if they're so short-lived, then deprovisioned containers, whether they be EC2 or Lambda, or Docker, they're historically interesting, because when they were around, they were providing value. And so you don't want to just get rid of them, because if you want to look at what happened, you really want to get a kind of aggregate view of everything. And that includes the containers that aren't around anymore, because while they're around, they provided value, and you want to understand what that value was versus the performance issues, or if there were some errors that were occurring. And so the other thing is that, raw metrics aren't enough. They're sort of the table stakes. I think we want to get above the level, and this is sort of what I'm thinking about is like, I want to get above the level of looking at the individual infrastructure elements and understanding their performance characteristics. I need that to start with, but what I really want to think about is what I call like computational intent. And when I'm running all those Docker containers, are they doing the same thing or not? And if they are doing the same thing, how do I understand what they did when they were all around? And so that computational intent that's embedded in it. So this is the New Relic servers view. And that makes sense if it's bare metal or VMs, these long-running things. This is the whole puppies versus cattle analogy, and that's all I'm going to say about it because I think it's a terrible metaphor. But if you're familiar with it, this is the puppies view. And so there's not too many of them, and they're long-lived, and so you want to carefully look at what's going on with them. But it's not interesting if you have, I think at one point we were ripping through 60,000 containers a day for running insights, and I'm sure it's much more now. It's probably well over 100,000 containers a day. Well, I'm not going to give you a list of 100,000 here. So instead, what I want is a view like this, and this is a view from our Docker monitoring solution. And what it does is it rolls up now. You can, in our Docker monitoring, you can look at it per container. You can understand the performance characteristics. You can go from the application down to the containers. You can go from the server up to the containers. And you have this additional view, which was us trying to understand this sort of what's happening at the macroscopic level. This view is a roll-up view where we've taken all of the containers, and this is a view from inside our data center, by the way, since we use Docker and we're monitoring it. And so you can see we've got our Insights product, and in fact, we've got two versions of our Insights product, and we put, not only do we know it's Insights, but we put the SHA into the names as a kind of version identifier. And so these are all the containers, all the Docker containers that we're doing Insights are all purple, and we've aggregated all their performance. In this case, it's CPU. So we're looking at the CPU usage of all of the containers together that we're doing the same thing. Now, on that server, we're running different workloads because that's a good way to use Docker, where you have it distributed different kinds of workloads. You get more efficiency out of the use of the server itself. So these are all things that are running on that same server. And you can see that we did a rolling deploy. The green moving to the purple here was a rolling deploy of Insights. And of course, what we did was we provisioned a whole new set of Docker containers with the purple ones, which are new version. And we started switching traffic over. So they started taking CPU, and the other ones weren't getting CPU anymore. And you got a deploy marker for free. Like there's no, we do deploy markers in New Relic, but this is a free deploy marker just because that falls out from the visualization, because you can see the traffic being switched over. And so that's the thing that I'm sort of really interested in us exploring is what does it mean to look at a macroscopic level at behavior? And that's really when I think about analytics from the point of view of infrastructure. It's about analyzing the overall behavior, the trending. And I think Opsmatic is an interesting angle on that of looking at configuration drift, which is again getting above the level of individual servers, but understanding how they're changing as a whole, one cluster versus another. Is there inconsistencies in the cluster? That's getting up above the level. So you heard in the keynote, you might have already heard about it, we have an EC2 beta that's out. And I'm running short on time, so I'll sort of skip through a little. But basically what it does is you've still got your application monitoring, you've got your server monitoring, and then we're also pulling in metadata from AWS. And that metadata provides us the context around what's going on. And that's our first foray into understanding, from AWS's point of view, how you're using, not only what the performance characteristics are from an application point of view and from an OS point of view, but also from AWS's point of view, how they're being used. And I don't mean CloudWatch. We'll get to CloudWatch eventually, but we're not including CloudWatch in here. What this is about is just understanding like what regions it's running, and I'll show you that in a moment. So it's SaaS to SaaS. If you're familiar with AWS, you just set up an IAM role. It takes you literally under a minute to get this set up, and it's a SaaS to SaaS connection from New Relic to your AWS account, and you're off to the races. That's all you have to do is just configuration. And at this point, I'll switch over to demo because I'm feeling cheeky. And I don't know how well you can see this. So how many of you are familiar with labels in the server monitoring product? Okay, some of you. You probably haven't used it too much because it's only useful if you put labels in it. And to get labels in, you probably put in your config when you're doing your deploy, or there's an API for putting the labels in. But what we did was we pull in all of that AWS metadata, like the region you're running in, or the AZ, the instance type, and we're populating those automatically as labels. So what you see here is a list of servers, but it's actually not a list of servers. It's a list of EC2s. It's a combined list of servers and EC2s. And in fact, if we scroll down here, I have an example here. I'll go to the next page. You can see that one of them is stopped. So that's the AWS state now. So we know that the container has stopped. And if you've used New Relic and you used server monitoring in AWS, you were probably screaming at us all the time because when you would deprovision your containers, the server monitoring agents in them would stop reporting. Oh, we're out of time. And so we wouldn't know, so we just leave them around. So now we can clean up the list. And I'm just going to show you some pivoting here that we can do. Last thing. I know, we're out of time. Last thing.
Oh,
so you can grab, you can do by availability zone, you can do by instance type, you can filter, and you can do roll-ups. So come by the booth and check it out. I think you'll find it's really interesting. I think it is anyway. And if we just drop back to the slides just for a moment. I can share these out with you, but this is our use. This is us monitoring us internally. And what fell out from this was we noticed that, boy, we're using a lot of different types of instance types, and maybe we didn't really mean to be. And in fact, this is by AZ, and we found out that we weren't deployed evenly. So these are the kinds of insights you're going to be able to get from the EC2 monitoring solution. So thank you very much.
Thank you.